Every day as we walk to school or go about our routines, we encounter countless objects: buses, cars, trees, animals, and even flowers. Have you ever wondered how we actually see these things? Imagine walking the same path at night when everything is pitch dark. Suddenly all those familiar objects disappear from view. If you enter a completely dark room, you won't be able to see anything at all. But the moment you light a candle or turn on a torch, objects become visible again. This simple experience shows us that light is essential for seeing. Without light, our surroundings remain hidden. Light helps us perceive the world around us. Objects like the torch, bulb, or the sun emit their own light. These are called luminous objects. During the day, sunlight allows us to see everything clearly. Luminous objects are special because they generate light themselves. On the other hand, things like chairs, paintings, or shoes don't emit light. We see them only when light from a luminous source falls on them and then travels to our eyes. This distinction helps us understand why some objects glow while others simply reflect light. Objects can be grouped based on how they interact with light. If you can see clearly through an object, it's transparent. It allows light to pass through completely. If you can see through it but not clearly, it's translucent. Light passes through partially. If you cannot see through an object at all, it's opaque. It blocks light entirely. This classification helps us understand why some materials let us see through them while others don't. Everyday items like glass, tracing paper, and cloth can be tested to see which category they belong to. Let's try a simple activity. Gather objects like an eraser, plastic scale, pen, pencil, notebook, single sheet of paper, tracing paper, or a piece of cloth. Look at something far away through each item. Is light able to travel through any of them to your eye? By recording your observations, you'll notice that some materials are transparent, some are translucent, and others are opaque. This hands-on experiment makes the concept clear and relatable. Have you ever noticed your shadow in a dark room or at night? Shadows don't appear unless there's a source of light in an opaque object. When light hits an opaque object, it can't pass through, so a shadow forms. Shadows are fascinating because they reveal the outline of objects and sometimes even help us identify them. Try drawing the outline of a shadow and see if your friends can guess the object. Shadows require both light and an opaque object to be visible. Understand shadows better. Hold an opaque object in sunlight slightly above the ground. You'll see a dark patch, the shadow on the ground. Sometimes you can even identify the object just by its shadow. Spread a sheet of paper and draw the outline of the shadow. Ask your friends to guess which object it is. Shadows give us clues about shapes, but sometimes they can be misleading. They depend on the light source, the object, and the surface where the shadow falls. Try this activity in the evening. Go out with friends, a torch, and a large cardboard sheet. Shine the torch upward so its light falls on your friend's face. If there's nothing behind your friend, you won't see a shadow. But if you place the cardboard sheet behind them, a shadow appears. This shows that shadows are visible only on a screen like the ground, walls, or cardboard. Everyday shadows are seen because surfaces act as screens. Shadows can only be seen on a screen. The ground, walls, or any surface can act as a screen for shadows. Sometimes shadows give us information about the shape of objects, but they can also mislead us. For example, you can create animal shapes with your hands and make-believe shadows. This playful activity shows how shadows can be manipulated and interpreted in different ways. Shadows can sometimes look very different from the actual object. For example, a long box's shadow changes size depending on how you position it relative to the sun. The shortest shadow appears when the short side points towards the sun. This observation helps us understand how the angle and position of objects affect the shape and size of their shadows. Did you know you can make a simple camera at home? A pinhole camera is easy to build using 2 cardboard boxes. Cut open one side of each box, make a small hole in the larger box, and cover a square opening in the smaller box with tracing paper. Slide the smaller box inside the larger one. Now you have a pinhole camera. Use a piece of black cloth to cover your head and the camera, and look at distant objects like trees or buildings. Make sure the objects are in bright sunlight for best results. If you look through your pinhole camera, you'll see images of vehicles and people moving on the road. Are the images erect or upside down? Do they show the colors of the objects? Try imaging the sun with your pinhole camera. Hold a cardboard sheet with a small pinhole in the middle and let its shadow fall on a clear area. You'll see a small circular image of the sun in the middle of the shadow. During an eclipse, you can observe the sun's image gradually becoming darker. Remember, never look directly at the sun. It's harmful for your eyes. Nature sometimes creates pinhole cameras for us. When you walk under a tree with lots of leaves, you might notice small patches of sunlight on the ground. These circular images are actually pinhole images of the sun. The gaps between the leaves act as pinholes, and even though the shapes are irregular, the images of the sun are circular. Try to spot these natural pinhole images next time you're outdoors. Let's explore how light travels. Use a pipe or a long rubber tube and light a candle at one end of the room. Look at the candle through the pipe. Is it visible now? Bend the pipe a little and try again. The candle disappears from view. This experiment shows that light travels in a straight line. When opaque objects block its path, shadows form. This principle explains why we see shadows and why light doesn't bend around corners. Mirrors are a part of our daily lives. When you look into a mirror, you see your own face, a reflection. Mirrors reflect light, allowing us to see images of ourselves and other objects. Sometimes you can see reflections of trees, buildings, or even the sky and water. This phenomenon occurs because mirrors and smooth surfaces change the direction of light, creating clear images. Try this activity at night or in a dark room. Ask a friend to hold a mirror at one corner while you stand at another corner with a torch. Cover the torch glass with your fingers, leaving a small gap to create a beam of light. Direct the beam onto the mirror. You'll see a patch of light reflected onto another friend. This experiment shows how mirrors change the direction of light, allowing us to see reflections even in darkness. Fix a comb on one side of a large sheet and a mirror on the other. Spread a dark colored sheet between them. Shine a beam of light through the comb towards the mirror. You'll observe a pattern that shows how light travels in straight lines and gets reflected. This activity visually demonstrates the path of light and how mirrors redirect it. This experiment helps us understand the manner in which light travels and gets reflected from a mirror. By sending a beam of light through a comb and observing its reflection, we see how light can be manipulated and redirected. Such activities make the concept of light reflection more tangible and fun. Let's recap the key ideas. Opaque objects do not allow light to pass through them. Transparent objects allow light to pass through, letting us see clearly. Translucent objects allow light to pass partially. Shadows form when an opaque object blocks light. A pinhole camera can be made with simple materials and used to image the sun and brightly lit objects. Light travels in straight lines, and mirror reflections give us clear images. These concepts help us understand the nature of light and vision. Let's classify some common materials. Air and water are transparent, allowing light to pass through. Piece of rock, sheet of aluminum, mirror, wooden board, and wall are opaque. Sheets of polythene, CD, smoke, fog, and cellophane are translucent. Some objects like the sun, firefly, and light torch are luminous, while others like the moon, umbrella, and cardboard are non-luminous. Understanding these properties helps us identify how light interacts with different material. Can you create a shape that gives a circular shadow when held one way and a rectangular shadow when held another way? Try experimenting with different objects and angles. This challenge encourages creativity and helps you understand how the orientation of objects affects their shadows. In a completely dark room, if you hold up a mirror in front of you, will you see your reflection? The answer is no. Without light, mirrors cannot reflect images. This simple observation reinforces the importance of light in creating reflections. Make a row of friends standing in a line. One friend stands in front holding a mirror towards them. Each person tells who they can see in the mirror. If a can see B can be CA, this activity teaches us about the way light travels and gets reflected from mirrors. You'll learn more about this in higher classes, but it's a fun way to explore reflections. Take a comb in your right hand and look at yourself in the mirror. Notice which hand appears to be holding the comb in your reflection. Mirrors seem to turn right hand into left and left into right. While a pinhole camera gives upside-down images, mirrors flip sides. This interesting observation shows how reflections can change our perception. Let's make a periscope, a device that uses reflections to see around corners. Place two mirrors in a Z-shaped box. Ask a friend to stand outside the classroom with a mirror and another inside with a mirror. Adjust the mirrors so you can see objects around the corner. This device is used in submarines and helps us understand the practical use of reflections. You can make a simple periscope by placing two mirrors in a Z-shaped box. This allows you to see over walls or around corners by reflecting light from one mirror to another. Periscopes are used in submarines and other places where direct sight is blocked. This activity brings science and creativity together. Opaque objects cast shadows, but what about transparent objects? If you hold a transparent object in the sun, do you see anything on the ground that hints you're holding something? Transparent objects don't cast clear shadows, but sometimes you might see a faint outline. This observation helps us understand the difference between opaque and transparent materials. Changing the color of opaque objects doesn't change the color of their shadows. But what happens if you place an opaque object in colored light? Try covering the face of a torch with colored transparent paper and observe the shadow. You might notice the shadow takes on a tint from the colored light. Evening shadows can also appear different as the sun sets, creating beautiful effects. Rudyard Kipling's story describes forests full of stripy, speckly, patchy shadows. Shadows create a mysterious and beautiful atmosphere with little pieces of light scattered among darkness. This poetic description helps us appreciate the artistic and natural beauty of shadows in our environment. Throughout this journey, we've explored how light helps us see, how shadows form, and how reflections work. We learned about transparent, translucent, and opaque objects, built a pinhole camera, experimented with mirrors, and even made a periscope. Light travels in straight lines, and its interaction with objects creates fascinating effects. Understanding these concepts not only explains everyday phenomena, but also inspires creativity and curiosity about the world around us.